Okay, now this is our third video on a unit number 2 linear data structure, and our chapter is what? Array. Okay, so we have already conducted two video lectures on the chapter array. This is our third video lecture. Okay, now in a second video lectures we will discuss about what? Two-dimensional array. So I hope now all of you are aware about how to work with a two-dimensional array. Okay, in that we have discussed all the points which are related to what? Two-dimensional array. Okay, we have already discussed about how to declare a two-dimensional array. Okay, this is a representation of two-dimensional array. Okay, then how to initialize two-dimensional array. Okay, we can initialize at the time of declaration as well as runtime initialization. Okay, now when you are trying to take a data in a two-dimensional array from a user side, okay, so we'll have to work with a what? Nested for loop. Okay, so I have already explained in a previous video about the working of a nested for loop. Okay, you can understand through these examples. Okay, and we have already discussed about this simple in two-dimensional array input output program. Okay, first we'll scan all the elements and then we'll display all the elements. Okay, now in these video lectures we are going to discuss about a what? Array representation. Okay, so now when you want to represent an array, so we are having two ways. Okay, either you can go by row wise or you can go column wise. Okay, so we are having two kind of representation. First one that is known as a row measure representation, and another one that is known as a what? Column measure representation. Okay, so the first technique is row measure representation. So now you have to understand the difference between these two methods, row measure representation and column measure representation. Okay, so the first method is what? Row measure representation. Now what exactly the row measure representation is? If the elements are stored in a row wise manner, then it is called row measure representation. So what we can say up to now, whatever the example that we have discussed, in that all that exam all the examples we have already worked with what? Row measure. But you people are not aware about that thing, this is a row measure. But here you can understand how exactly the row measure representation will work. If the elements are stored in a row wise manner, then it is called a what? Row measure representation. So now what exactly the row measure is? Okay, like let's take one simple example. If you will understand this example, so it will become too much easy to understand. Like if you want to store element like 10, 20, 30, 40, 50, 60, 70 and 80. Now, but before that, you must need a size of array. Let's say, for example, our array size is what? A34. It contains total number of row 3 and the total numbers of columns are what? 4. Okay, so now if you will observe this table, here we are having total 3 row. The index will be 0, 1, 2. We'll have a 4 column 0, 1, 2 and 3. Now here we are going to store a element one by one. Okay, so first element will be stored at which index? And row number 0, column number 0, row number 0, column number 0. So the 10 will be stored at A00 location. Similar way, next element will be stored at, here we are going to store all the element row wise. So obviously we will continue in the same row, correct? So the next element will be in a row number 0, but column will be what? 1. So the 20 will be stored at which location? A of 0, 1. 0 and 1 intersection at these points. So 20 will be stored at these position. Then next element will be stored at what? Same row. The column will be what? 2 index. Row index will be 0 and column index will be what? 2. So the 30 will be stored at A of 0, 2. Similar way 40 will be stored over here. Correct? Now here maximum column we are having 4. So the index will be up to 3. Now when you will reach to that index, maximum index of column, then again we'll move to the next row. So now the row will be what? Row index will become 1 and the next element will be stored at what? Row number 1, column number 0. So the location will be known as a what? A of 1, 0. So 50 will be stored here, then after 60, then after 70 and then after 80. Now still if you are having some more elements, so it will be stored at which row index? Second. And the column index will be what? 0. So if suppose you want to insert still some more elements, okay, so that will be started from a next row. So now if you have observed all the elements which we are going to store in an array, that all are going to be stored in a which manner? Row wise. Okay, first your first row will be finished, then we'll move to the what? Next row, correct? And then after next row. So all the elements here are going to be arranged in a row wise manner, and that is why it is known as a what? Row measure representation, correct? So this is very easy to understand what exactly the row measure representation is. And the second method, that is what? Column measure representation, correct? So if the elements are stored in a column wise manner, then it is called what? Column measure representation. So now instead of row, now we'll fill up all the elements in which manner? Column wise. So obviously first all elements will be entered through a first column, then you will move to the next column and next, like that. Suppose same, we can continue with the same example. If suppose you want to store the element like 10, 20, 30, 40, 50, 60, 70 and 80. And suppose we are keeping the same size of array, okay, like a3 4, so it's having 3 numbers of row and 4 numbers of column. So okay, so now in this case, if you are trying to store all the elements column wise, okay, so the first element obviously it will be stored at which index? 0 0. So now 10 will be stored at what? 0 0. Now the next element 20 is going to be arranged at this location. Now see here, in earlier case row wise we are trying to fill up all the elements row wise. So first whole row complete, and then after you will move to the next row. Now here what we are trying to do, we are trying to fill up all the elements in a column wise manner. So first we'll have to complete the first column, then after you will move to the what? Next column, okay? So now the first 10 will be over here, then after 20, then after 30, then after 40, 50, 60, 70 and 80. So this is the case, correct? Okay, here we are going to arrange all the elements of a two-dimensional array in a column-wise manner. Okay, so the first column number is column index 0 will be filled. Then after column number 1 index filled. Then column index number 2 will be filled, like this onwards. So here in this case, we are going to store all the elements in a which manner? Column-wise, and that is why it is known as a what? Column measure representation. So now the question is what? You can store all the elements in a row wise manner as well as what? Column wise manner. Okay. So these are the two basic representation in a array: row measure and column measure. Okay. Now this is very much important topic of this chapter, that is address calculation of array elements. Now what exactly this is? Okay, now if you will observe this, okay, whatever the element that you are going to store in an array is having some address. Okay, so the now question is what? Okay, how you can calculate the address of any element which is stored in an array? Okay, because all elements are stored in a memory. Okay, actually your array elements are stored in about your RAM, and whatever the value which are going to store in a RAM, definitely it will have some address. So now suppose if you are having a two-dimensional array and randomly you will choose, okay, if you want to identify the address of this particular element, okay, so that you can find it out. Okay, so now to calculate the address of any element, you must know some parameters. Okay, you are not able to directly do this particular task. Okay, first you must need some basic information, correct? So what kind of thing which you need? So the first thing which is required, that is known as a base address. So first you have to understand the base address. So you have to understand what exactly the base address is. So that is nothing but address of first element. So obviously in array we are having index 0, that is the first. So at index 0 0 we'll have first element. So you must know the base address. So that will be address of first element and which is stored at index 0. So you must know the address of your first element. If you are not aware about this base address, then you are not able to calculate it. So this is a must required field. Second thing, you must know data types of array. Why? Because whatever the array that you are taking in your example, you must know the types, data types. Okay, either it is integer type or a float type. Because the thing is what? Okay, based on the data type, we can identify that okay, these particular element will occupy this much amount of bytes. Okay, if suppose you have declared an integer type of array, so it will occupy 2 bytes. If suppose you have declared your array as a float type, so obviously the float element will always occupy 4 bytes. Okay, because we'll have to identify that either these particular elements belongs to integer or a float, because in both the cases it will occupy the different number of bytes. For integer it will occupy 2 bytes, and for a float it will occupy a 4 bytes. Third thing that you should know, that should be a size of array. Obviously when you are trying to calculate the address, you must know the size of array. Okay, what exactly the size of your original array. Fourth thing, that is what? A representation of array. Because when you are trying to calculate the address, so before that we are having one question. Okay, either you are going to arrange your elements in a row wise or a column wise. Because in both the cases you will get a different result. See, correct? If you are arranging all the elements in a row wise manner, or if you are going to arrange in a column wise manner, so in both the category will have a what? Different result. Okay, so before that you must be aware of, you must know either the elements are going to be arranged in a row wise manner or a column wise manner. And fifth thing that you know, the index of element for which you want to find the address. It means what? You must know the index of element for which you want to find the address. So obviously this is a required data. Okay, like you have to specify that which elements address you want to find it out. Correct? So this is the definition. Okay, you have to specify the index of the element for which you want to find a what? Address. So this is must required. And the last thing, we are having some formulas. Okay, we can work with that all formula and we can calculate either row wise or a what? Column wise. Correct? So we can work with both the we can work with both method. Either you can calculate with the row measure or a column measure. Okay. So now in an exam you can have this kind of question. Okay, you can have this kind of sums. Okay, these all basic information that is given to you, and based on using that formula you have to calculate the address of a specified elements. Okay, you have to calculate the address of a specified elements. Okay, so now here if you will see at first thing, it it look like too much difficult, but actually it is not that much difficult. Okay, it is too much easy. So formula for calculating the address, so for both the cases either you can go for a row measure or you can go for a what? Column measure representation. Okay, so for both we are having different formula, but both the formula is having a minor change. Okay, the address of a location in a row measure system is calculated using which formula? Here you can see the address of aij. Now what is this aij? Aij is nothing but the index of the element for which you are going to find a what? Address. Okay, so you must have to understand each and every parameters of this formula. Okay, so now let's see. Here we are having what? B plus W into bracket N star I minus LR plus J minus LC. So now it is too much easy. Now this B stands for what? Base address. So that is what? Address of first element that is given to you in an example. Okay, that base address is given to you in an example. Now that next element is what? W. So now here you can see W is what? Storage size of one element stored in an array. As I already explained you, if it is an integer type array, it will occupy 2 bytes. And if it is float, then it will occupy 4 bytes. So W can be either 2 or 4. If it is integer, the value of W will become 2. And if it is float, then value of uh, W will become what? 4. Now what is this I and J? So I is what? Row subscript of element whose address is to be found. So the you must know the index of the elements for which you want to calculate the address. Okay, so now here you can see the row subscript that is already given to you. Okay, you have to find out the, suppose say for example A23, that is given to you. So I is 2 and J is what? 3. Okay, so now J is nothing but it is a column subscript. So that is the question. Okay, for these particular index you have to find out the address. Now here you can see LR. LR is what? Lower limit of row or a start row index of matrix. In all the example it is not given. Okay, that we will discuss in a detail when we are having a numbers of example. But here you can see if not given, assume 0. Similar way, lower limit of column, or we can say the start column index of matrix, if not given, then assume 0. Okay, now the value of M, it indicates what? Number of row of the given matrix. Okay, the input matrix that is given to you, the original matrix that is given to you with a size. So when based on the size, are you able to tell me that that matrix is having how many numbers of columns as well as how many numbers of columns? So M indicates number of row in a given matrix, and N indicates what? The numbers of column of the given matrix. Okay, these all are the parameter that we will discuss in a detail when we'll have an example. Okay, but you have to keep in mind this formula. Based on that formula, you can calculate the address. Either you can go row wise and column wise. Only the minor difference is there. If you will observe these two, here we are multiplying in a row measure. Here we are multiplying this term with number of column, that is what n. And in case of column measure, here we are multiplying with the numbers of row. See, only the one difference is there. Okay, so now we are keeping up to this in this video, and we'll discuss the more examples actually which are asking in a what exam. Okay, so we'll take 2 or 3 examples and we'll discuss how exactly this formula is working to calculate the address of any element of a word array. So that all things will cover in a next video. Okay.